In this project, we address trustworthy AI from a data-centric point of view. It's a well-known fact that AI models have always needed data to work. But we can see that over the years, the thinking about this data has evolved. Sorry. Yes, you know the famous Andrew Ng, that he said a few years ago that data was the fuel of AI. AI was seen as a rocket, and we need a lot of data to obtain powerful AI. But now his speech is more nuanced and concerns the interest of research focus on data. Now that AI models and their architectures have well progressed to solve downstream tasks. And this is a hot topic. It is no longer a question of abundance, a mainstream word these days in France, but it's a question of trust, relevance, and quality. We need quality data set adapted to our use cases and efficiently prepared upstream to solve downstream tasks. And in the data lifecycle, some questions can be raised and are not yet answered, like which data we want. Is my data adequate? Can I trust my data, or how to process large volume of data? And this is what we want to address in this project. And to do that, we consider as input real data and synthetic data. And of course, we want to take into account the operational domain and the data specification that are defined previously. And the objective is to construct a relevant data set associated with metrics to ensure data quality and good domain coverage. And so the objective is to develop methods and tools to design and analyze the data set in construction.
Thank you, Angélique. So to follow up, so as Angélique said, we want to design these methods and tools to articulate between the world model, which is the description of the requirements, the operational domain, so things defined at the system level. We want to articulate that with the real world and the synthetic world, where we want to take our data. So to do that, we propose to create a common language description, to have really a way to interact between all of these three words. And so this is where the activities we do in our project get involved. So we see that to go from the world model to our common language description, we need to specify our data, the data we need to acquire. So here we take the example like a world where we have, we want to, our operational domain is, for example, America and Africa. So we want to specify that. It will help us then to get our data. Then when we have this common language description, we need to have methods and tools to collect, analyze, prepare, and select our data into the real world. But we also need to take into account, for example, here, an update to North America, and so to ways to update our data sets and adapt to new domains. The other way is to take into account the synthetic world, so because it's useful to take synthetic data, for example, in situations we can't acquire in the real world. So we need ways to generate and augment our data with simulation, but also we need to take into account that our synthetic world is really representative of our real data. And the other way is really to use this synthetic world to ensure the coverage and achieve the completion of what we acquire in our real world. To finish this presentation, we will do a snapshot on 3 parts of it, but we cover all of the subjects. So we encourage you to come visit us at our village, which is right by here, to have more information. So one aspect is collection, analyze, and preparation of data. So to do that, we develop a data platform. So with a strong link to what Yves just presented you. So we have designed this data platform inserted in this MLOps platform. It's a modular environment to manage our data end-to-end. So to do several steps really important to treat our data. So for example, annotation or visualization or data analytics, but also several tools in order to ensure integrity of our data end-to-end, so tools to compute versioning, and we also have like a common data model to make sure that we keep integrity of our data from one tool to another. We have a demo of our data platform at our village that you can see after that.
And so we have a data platform that is already functional, but we want to improve this platform with the new smart component, and we are already doing that. With this first example, in this example, we have developed an algorithm that allow a selection of relevant unlabeled data from a large batch of raw data. And the idea is to update the initial data set and to obtain a better coverage of the operational domain. And with this selection, and we can have a reduction of the annotation cost, since we only annotate the relevant data. And this is also beneficial for the AI module, since we can increase the AI performance by comparison with a random selection. And another example is the idea that we want to adapt to new domain, our models, and we want to enrich our dataset with a lot of raw unlabeled data, and we don't want to annotate them. So the idea with the previous one was active learning paradigm, sorry. And this one is, I am talking about unsupervised domain adaptation paradigm. And with this paradigm, we can update the dataset and increase the coverage of the operational domain, and we don't need to annotate anything. And we can also increase the AI performance by comparison with direct transfer.
And to finish our presentation, we want to give a quick information on generation and augmentation with simulation. So to do this activity, we are working with 4 startups. I won't go into details on the techniques that they're working on, since we have a full workshop about that later on today. But I want more to give you some info about what are the objectives of this activity. So to do that, we didn't want to look at synthetic data sets for training, but to look at them if they were interesting for validation purposes. And we want to answer to several questions. First is, can we use synthetic data sets to to build an extensive data set that is covering the full ODD of a use case. So we have started with the use case where we have several requirements, and we're building these synthetic data sets to cover all of them with the animation of character, etc. So the idea is, since it's complicated to have all of the situation we want in the real world, can use the synthetic world to build, I would say, perfect validation data set, but with synthetic data. So it's the first objective. The second one is which are the best techniques, I would say, to do that, and can we obtain synthetic data that is representative enough of the real world. So we're testing several types of image rendering or style transfer techniques, etc. You will see them later, but really to keep in mind the objective of what we have for this activity. And so to finish, a few examples of what we're doing with the startup Jolly Brain, where they're doing style transfer image to image in order to improve the, to augment the image we have in another situation. So, for example, here you can see you can go from day to night, or these examples here. And to finish, maybe you will see with better here. It's an augmentation with, this is the original image, but with different level of snow. And you see it's really impressive images. So if you want to have more information about it, you can see us at our village or go to the later on workshop. Thank you.